well. My name is Sanjeet and I'm an instructor at Level powered by an academy. So, in this video, we are going to discuss a problem with the name Count Beauty. What you can expect from this video is, so we will be discussing the problem statement of this, and then we will discuss the approach that how you can solve this particular problem, and later on we will implement this with the code, right? So let's just move forward. Here the problem statement says that you can consider a number n which can be represented by digits as d1, d2, d3, dk, right? Where di denotes the ith digit from left in n. We define f of n as summation of di plus I, its modulo by 2, where your I can start from 1 and go till k, right? Now, a number n is called beautiful only if f of n is greater than 0. Now you need to count how many beautiful numbers exist between L and R where both are inclusive. For example, let n is equals to 286. Then we are taking all the digits one by one, for example 2, 8 and 6. Then we are adding that on which ith index they were. So 2 is on first index, so that's why we are doing 2 plus 1. 8 is on second index, that's why we are doing 8 plus 2. 6 is on third index, so we are doing 6 plus 3. And we are taking modulo of all these three numbers by 2, and then we are adding them. So the summation gives us 2. As f of n is greater than 0 now, so n is a beautiful number, right? For example, there is a number 5. If you will do 5 plus 1, it would become 6, as 5 is on first index. And if you will take its modulo by 2, so 6 modulo by 2 would give you 0. As f of n is not greater than 0, so that 5 won't be a beautiful number, right? Here, the constraint is that L and R can be in the range of 1 to 10 raised to the power 18, and all your input value would be integers. Your input format would be, you would be given two space separated integers L and R. Your output format would be, you need to print the count of beautiful numbers in the range of L and R, right? So for example, from 2 to 10, there exist 4 beautiful numbers. So let's just see how we can solve this particular problem. So here I have just tracked the problem statement just for your reference. So for example, you have given a number n. Let's consider that particular number as, for example, 1, 8 and 9. Okay, we are taking a random number. Then it says that it is having digits as d1, d2, d3 till dk. Okay, so let's say to this digit we are calling as d1. Your next digit would be d2 and next digit would be d3. This whole number is n, right? Here di denotes the ith digit from left in n, right? So di is the ith digit from n. So here if we will take the values of I, so here value of I is 1, here value of I is 2, here value of I is 3. So this is your first digit, 8 is second and 9 is third digit. Now what we have to do, we have to take the summation of this. What is this? So here it is saying that your value of I is varying between 1 to k, where k is number of digits in this number n. Okay, so here your k would be 3, as there are 3 number of digits in this particular number n, 1, 8 and 9. So here we are supposed to take sum of di plus I and take their modulo by 2, where your I can vary from 1 to k, right? So this would give you f of n. If your f of n would be greater than 0, then we would say it is a beautiful number. Otherwise, it won't be beautiful. So if f of n is smaller than or equals to 0, then not beautiful. Cool. I hope you have got the problem statement, right? Now what the question says that you need to count how many beautiful numbers would be there between L and R. Both are inclusive. So for example, if it is given to you that L is 20 and R is 10. So in sample input, as it is given to you that L would be 2, R would be 10. So here is a range of numbers given to you from 2 to 10. And you have to find out that how many beautiful numbers would be there. So let's list all the numbers that you need to check. So 2, 3, 4, 5, 5, 6, 7, 8, 9 and 10. These are all the numbers that we need to test. Then for every number, we would be checking is it beautiful or not using our formula that we need to take the sum of d1 to dk, using our formula that starting I from 1 to I is equals to k, and we would be taking the sum of di plus I and taking its mod by 2, right? It would give you f of n. So let's see. Firstly, get the f of 2, where value of n is 2, right? So here in 2, we are having only one digit, that is 2. What is the ith index of this digit? It is 1. So 2 plus 1, 3. And we will take its modulo by 2. So 3 modulo by 2 would give you 1. So basically what this modulo gives you the remainder. This gives you the remainder. Okay. So when you would be dividing 3 by 2, you can see 2 into 1 would be 2, and on subtracting you will get this remainder. So this remainder is the output of this modulo operation, right? So here you can see this f of n would give you 1, which is greater than 0. So that's why it is a beautiful number. So if we have a count of beautiful numbers, we can update that count. So count would become 1 now that we have got at least one number which is beautiful. Now let's move forward. So we are done for 2. Now let's check for 3. So we will do f of 3. 3 is only one digit. We will just do 3 plus 1 modulo by 2. So 4 modulo by 2. So when you will divide 4 by 2, remainder would be 0. So here you can see it's not a beautiful number. Your count won't be updated. It's not a beautiful number. We will move forward to 4. So f of 4 is equals to 4 plus 1 modulo by 2. It would give you 5 modulo by 2. And as you know, 5 modulo by 2 would give you the remainder 1. So yes, it is a beautiful number because f of n that we are getting is greater than 1, right? So your count would be updated to 2. Similarly, we would do for 5. So here you will do this. F of 5 is equals to 5 plus 1 modulo by 2 is equals to 6 modulo by 2 would always be 0. So it's not beautiful. So 6 is not beautiful, right? 5 was also not beautiful. Only your 4 was beautiful and 2 was beautiful, right? So now when we will come to 7, on 7 you can see. So now when we will come to 6, on 6 you can see f of 6 would be 6 plus 1 modulo by 2. So 7 modulo by 2 will give you 1. So it's a beautiful number. So we can say, okay, 6 is also a beautiful number, right? As we have just checked for 6. Now we are checking for 7. So by now you must have got the idea that f of 7 won't be a beautiful number because plus 1 would make it 8 and 8 modulo by 2 would give you 0. So it won't be a beautiful number. And similarly, as it won't be a beautiful number, 8 would be a beautiful number, right? Because 8 plus 1 would be 9. 9 modulo by 2 would give you 1. Next is 9. 9 plus 1 would give you 10. And 10 modulo by 2 would give you 0. So this is not beautiful. So till now our count is 2 was beautiful, 4 was beautiful, 6 was beautiful and 8 was beautiful. So by now our count is 4. Now let's come to 10. In case of 10, what we will do? So 10 is having two digits, 1 and 0. So we will add 1 to digit 1 and take its modulo by 2 plus 0 is your second digit. So we will add 2 to it and take its modulo by 2. Now let's see what would be your answer. So 2 modulo by 2 would give you 0 plus 0 plus 2 would be 2 and 2 modulo by 2 would give you 0. So again it is 0 and 10 is also not a beautiful number. So our final answer would be 4. That we have found total 4 beautiful numbers. Cool. So guys, I hope this particular explanation is clear to you and you are able to get that how you can find the all the beautiful numbers between your given left and right. Okay. So now let's see how we can implement this particular problem. So let's just implement the code. Here, according to the question, we would be getting two variables. First would be your L, and let's say value of L is 2, and next variable would be your R, value of R would be, let's say, 10. So what we are going to do, we have to count the number of beautiful digits. So we have to count the number of beautiful numbers, right? So here let's say let beautiful numbers count is equals to, so let's say we are making a call to function beautiful count, in which we are passing our L and R, and we are assuming that it would tell us that how many beautiful numbers are there between L and R, and at the end what we can do, we can just console.log your beautiful number count. Cool. Now let's just see how you can implement this beautiful count function. So I hope you are already aware about the syntax of function. So we will write the keyword function beautiful count. Here we will pass our two variables L and R, that is the value of your left and right. Here what we are gonna do, so firstly we will let's just take a count which is initially equals to 0. So right now there is no beautiful number. So here what we will do, we will just create a loop. Let's say n is equals to L. So n would start from L, n will go till your R, and every time we are doing n plus plus for the number. Okay. So what is our current number? Our current number would be n. So we have to check every time if our number n is beautiful or not. Cool. So let's say we are having let sum which is initially equals to 0. Now you have to take out the digits of your number n, right? So for that, as n is a number and we have to take out the digits one by one, so we would convert your n to a string and will treat each of its digits as the character. So we will do n dot to string. So it will convert your function, your number n to a string, and after that we can split your string on the basis of an empty string. So there is no space between your number. So that's why we are splitting it on the basis of empty string. So you will get an array of all the digits by this. Okay. You will be getting just an array of all the digits by this. After this, what you can do, you can just map your every digit. So you are mapping your every digit to a index. So let's say we are mapping our every digit to an index. So here, what we are gonna do for every digit, firstly we need to convert that digit to an integer, because right now it would be a character, as we have converted it to a string. So and we have splitted a string. So every digit would be treated as a character. Firstly, we need to convert it as an integer. Then we need to add idx plus 1 to it. Why idx plus 1? Just because your index would start from 0, but for first digit we want to add 1 to it, for second digit we want to add 2 to it. So that's why we are doing idx plus 1, because your index would start from 0 and we need to start it from 1. So that's why every time we will do just plus 1 to index, and we need to take modulo of this by 2, right? This is not done, this is still not done. We need to add this for every digit to our sum. So to make f of n, we need to add it to our sum. So we will add it to our sum. Cool. Now after this, we can just check if your sum is greater than 0. In that case, it is a beautiful number. So you can just increase your count as count plus plus. And at the end of this loop, when all the numbers would be considered between L to R, we can just return your count. So let's say return count. So now let's just see if the solution is working or not for us. Let's try to run it. Okay, so it is giving us some error that invalid left hand side in assignment. Okay. Oh, here we haven't given our arrow function. So it would be an arrow function not only equals to. Now let's just try to run it. So here you can see the output is 4, right? Which is the expected output that we were expecting. So I hope you are able to get this, that how we are solving this particular question. It was simple. We were going at every number, and for every number we are splitting its digit into a map where we are mapping every digit to an index 0, 1, 2, 3, 4, like that. But in the question it was given to us that for first digit we would be adding 1 to it, for second digit we would be adding 2 to it, right? As your index would be starting from 0, that's why we are doing idx plus 1. And and we are parsing your digit to an integer because here we have taken it as two string. So that's why we need to parse it to integer again, so to do some addition or division operation. After that we have taken its modulo by 2, and we have done this for every digit of a number. And at the end, if your sum would be greater than 0, then we can say it was a beautiful number and you can increase your count. Cool. If we will discuss the time complexity of this particular number, so it would be r minus l. So big O of r minus l, because we are just applying one loop of l to r. And the operation that we are doing here, that is splitting the digits and then working upon them, it is kind of a constant time operation because you are not getting that much big numbers, right? So that won't be taking much of your time, it would be some constant time. So that's why we can say here the time complexity would be big of r minus l, and there is no space complexity as we haven't taken any extra space. So I hope this particular explanation is clear to you and you would be able to implement it on your own as well. So thank you. Take care.
हाँ नींद तो लगता है डर